Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 82 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at SunFounder. SunFounder is actually sponsoring this most excellent series of video lessons, and in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, most of you guys probably already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in lesson number 81. But I must start by asking how many of you got the homework done. If you got the homework done, leave a comment down below. I am legend. Double chest bump. And if you did not get the homework done, leave a comment down below. I fold it up like a cheap Walmart lawn chair. But never fear, today I will show you my solution to that homework assignment. And what the homework assignment was really to get you to begin to become more familiar and more comfortable with using timers. And so what your assignment was to create a 4-bit binary counter using LEDs and using nothing but timers, not to have anything that you're doing in your while loop, in your main loop, but do the whole binary counting using only timers. Okay, hopefully you guys were successful. Let me get out of your way. Let's come over here and take a quick look at my circuit. The circuit is very similar to what we've been doing in these earlier lessons. I have the first LED, the first red LED is connected to GPIO pin 16. The next one, the long leg, to GPIO pin 17, the next one to GPIO pin 18, and the next one to GPIO 19. These are configured to where the right leg is the long leg. All the way around, it's long leg on the right, long leg on the right, long leg like that. The short leg of each LED is connected through a 330 ohm resistor to the ground rail. The ground rail is created over here with physical pin 38. We create the ground rail, and then you can see I'm creating a 3.3 volt rail, but we don't use that in this project. It's just I hook up a power rail just kind of out of habit when I'm building a circuit. So we've got all 4 LEDs done, and what we're going to do is using timers, we are going to create a binary counter. Now, what is it that I always tell you over and over? We need to get it working on paper before we try to jump in and start coding. So let's see if we can sketch this thing out, and let's just remind ourselves how a 4-bit counter would work. And so let's see if I can get this thing going here. Let me see if I can get a good color. Okay, so let's see if we can remember how binary counting goes. So we have a 0 is 0, 0, 0, 0, or off, 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 off. And then we're going to go off, 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 on. And then we're going to go off, off, on, off, and then we're going to go off, off, on, and then we're going to go off, on, off, off, and then we are going to go off, on, off, on, and then we are going to go off, on, off, and then we are going to go off, on, and then we are going to go on, off, 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 on, off, off, on, and then we're going to go on, off, on, off, and then we're going to go on, off, on, running out of space, on, off, off, and then we are going to go on, off, on. We're going to have to turn the title off, ladies and gentlemen, and still we're going to barely get it on here. And then we are going to go on, off, and then we're going to go on. Okay. Now, when you look at this, I want you to look at, this is the ones place, this is the twos place, this is the fours place, and this is the 8 place. Do you notice any trend here? This one is on, off. This is off, on, off, on, off, on, off, on. Every one cycle, that bit flips. How about this one? This one is off, off, on, off, off, on, off, off, on. This one flips every other cycle. Every second cycle, it toggles. Toggle. Think about that word. Now this one, it's every 4th time. So it's off, 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 on, off, 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 on. And then this one is every 8th cycle it toggles. So it's off, 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 and on. Okay, so you can see that each one of these is a factor of 2 off in its what? In its period. So this one is twice as slow as this one is twice as slow as this one, and this one is twice as slow as this one. We could also think of it as this one is twice as slow as this one is 4 times as slow as this one, and this one is 8 times as slow as this one. Okay, that's the way you can think about it. I don't like that title being off. It makes me look like I'm just floating in midair. So let's turn that title back on. All right, so that is the pattern that we are going to try to create, and we're going to try to create it how? We are going to create it using timers. So let's come over here. We've talked about the circuit. The circuit's all hooked up, okay? And then let's see here. I'm going to turn that off so you can see a little better. And let's come over here and just see if we can start coding this thing up. So we're going to say from machine import pin, okay? And then from machine import timer, and then import time. And then we're going to do our LED pins. Now, this is the way that I'm counting the LED pin. This LED is worth 1. This is worth 2. This is worth 4. This is worth 8. So this is going to be LED 1, 2, 4, 8. You might think 1, 2, 3, 4, but I'm going to put its value as part of its name. And that's just a little easier for me to keep up with. So LED value 1, that pin is going to be, what did we say, 16. LED 2 worth 2, pin is going to be equal to 17. LED 3 pin is going to be worth 18, and then LED 4 pin is LED 1 pin is 16. LED worth 2 pin is pin 17. LED worth 4 pin is pin 18, and LED worth 8 is equal to pin 19. Okay, so pin 16, 17, 18, 19 is the 1, 2, 4, and 8 pin. Okay, now let's go ahead and define our LED objects. LED 1 is equal to pin, and that's LED 1 pin. and that's a pin dot out like that. I think I'm going to just cut and paste this one. Okay, so I'm going to say C. I'm going to do paste. I'm going to do paste and paste. And so this is LED 1, this is LED 2, this is LED 4, and this is LED 8. Now this was LED 1, this was LED 2, this is LED 4, and LED 8. Why 8? Because that LED is worth 8. So I'm putting their worth value, their place value. Okay. Now let's come down here, and what I am going to do is I'm going to go ahead and I'm going to create my LED timers. And so LED, let me go ahead and create my toggle. Let me create my blinkers, okay? And so I am going to define LED. I'm going to define those callback functions. So LED 1 blinker of source, okay? And what is that going to do? That is going to need a semicolon. No, that's a colon. That's going to need a colon. And then what am I going to do? I'm going to do an LED 1 dot toggle like that, okay? And then what am I going to do? I think that is all I'm going to do there, all right? Now let's just copy and paste this thing. Okay, copy. All right. Let's come up here. Control V, enter. Control V, enter. Control V, enter, like that. Okay, so I've got 1, 2, 3, 4. So this is the 1 blinker. This is the 2 blinker. This is the 4 blinker. And this is the 8 blinker. This is the 2 place. This is the 4 place. And this is the 8 place. Okay. Now let's go ahead and let's create our timers. Okay. And so LED 1 timer is going to be equal to a timer. We're going to create our timer here. And then what is it going to be? It's going to be a period is equal to, I'm just going to call it BR for blink rate. And then here I can define the blink rate. I'm going to say blink rate is equal to 500. So that would mean 500 milliseconds. So the first LED should be 500 off, 500 on, 500 off, 500 on. And then what we're going to want here, we're going to want our mode to be equal to a timer dot periodic. Okay. And then the callback is going to be equal to that LED 1 blinker. Okay. And what does LED 1 blinker do? It blinks LED 1. Okay. Now I hate doing all this fancy copying and pasting because, man, there is no telling if you have a little mistake, you are really copying that mistake. But this is the LED 1. This is the LED 2. This is the LED 4. And this is the LED 8 timer. And similarly over here, 1, 2, 4, 8. Do you guys see that if you're mindful in defining your variables, how quickly and methodically things go? Yeah, easy to say when I haven't run the program yet, right? Easy to say when I haven't run the program right yet. Okay, let's just blink them all at the same rate, and then we're just going to see if that works before we go in and try to turn it into a binary counter. But let's get our bookkeeping done. So we're going to do a try, and that will allow us to cleanly exit the program. We're going to do a while true. When is true, true? True is always true. We're creating an infinite loop. And what are we going to do? We're just going to pass because all the work is being done where? All the work is being done with the timers, as was the homework assignment. Keyboard interrupt. You guys have gone through this before, so you really ought to know what I'm doing here. And so what are we going to do? We're going to allow ourselves to cleanly exit the program. So I'm going to say LED1 timer dot dinit, and then that is like that. Now what are we going to do? We're going to go fast and crazy here with our pasting. Tab, Control V, Tab, Tab. So we're going to turn dinit 1, we're going to dinit 2, we're going to dinit 4, and we're going to dinit 8, like that. Okay, now we're going to do an LED 1. We're going to turn the LED off just to clean the program up neatly. And then this is going to be a Control C, and then Tab, Control V, Control V, Control V, and this is LED 1, 2, 4, and 8. Now this, if we run it, we'll get our errors out. But if we run it, it should what? Just blink all of these together at a ½ second on, a ½ second off. So all eyes on the LEDs. I need you to hold your breath. Boom, look at that. They're all blinking. Each one has its own individual timer. Success. Okay, but you said, what is this success business? Your assignment was to create a binary counter. Okay, your assignment was to create a binary counter. But what do we see over here on the binary counter? The 2-bit, you can't see me pointing there. Let me see if I can get that. The 2-bit should blink half the rate of the 1. The period should be twice as much. The period here should be 4 times as much as the 1, and the period here should be 8 times as much as the 1, because when this one switches once, this one takes 8 cycles to do the same that this one does in 1. So the period would be what? The period would be 8 times as much. So let's come over here. So what we're going to want to do in the code view, so yes, Mr. Friendly One Place, he can just blink at BR, but our friend Mr. Timer 2 is going to need to blink twice that, or twice the period, which would be half the rate. This one 4 times the period, or 1/4 the rate, and this one times 8, which would be 8 times the period, 1/8 the rate. And so now let's Control C, and yes, indeed, we did cleanly exit. Are we ready? The moment of truth, please hold your breath. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 0. Back to 0. Giddy up. We got this thing. Now, is this not like the easiest way to make an LED counter? And what you can, oh, you didn't see that, did you? Okay, let's come back here. I didn't give you the right view. So let's run this again. Okay, I'm going to Control C to stop it. I'm going to come in here and run it. And then we have got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, back to 0. Okay, that works. You know what? Let's play around with this a little bit. What if we try to go faster? What if we took this to 100? Just because it's so easy to play around with this. Control C to cleanly exit, changed it to 100. Let's look at it. 1, 2, 3, 4. It's just really faster than I can count, but you can still see that it's working. What if we really wanted to go crazy with this? What if we went down to 10? Let's see if we go down to 10. Let's see if we can still see it. So let's watch it. Okay. You can almost see it there. This one is going so fast that you can't see it. This one you can see blinking, and you can kind of see that pattern across there. That's probably beyond what we can really see. Let's say if we go to 25, Control C to cleanly exit, and we come here. Yeah, I think that I can see that at 25. And so binary counter, man, the thing you can see is if you wanted to have like 8 or 10 LEDs, I'm not exactly sure how many GPIO pins we have, but if you wanted to have a lot of these things blinking, you would be able to do it, because it would be very, very simple to just extend this code to BR times 16, BR times 32, BR times 64. And so you can see that that would be pretty good. Okay, guys, I hope that you're becoming comfortable with using these timers, and I hope that you are becoming comfortable. I hope that you're becoming comfortable, what would I say, realizing the power of these timers. And I'm hoping that as you start coding, you'll start using these timers more and start using things like time.sleep a lot less. Okay, guys, I do not know of a good homework assignment to give you. Maybe you could add a couple of more LEDs to your project just to show that you can easily extend this to more. And then I'll probably next week, it's going to be a little bit different topic. I'll probably start talking about interrupts, kind of like hardware interrupts, which are very closely related to timers, but we'll look at hardware interrupts because they're also a very, very powerful thing that you should know how to do. Okay, guys, I hope you're having as much fun taking these lessons as I am making them. You can help me out by giving me a thumbs up. Also, it will help me with the old YouTube juice if you'll leave a comment down below. If you haven't already, subscribe to the channel. When you do, ring that bell to make sure that you get notifications when future lessons drop. And as always, I want to give a shout out to you guys that are standing with me on Patreon. It is your support and your encouragement that keeps these great lessons coming. So thank you for the support on Patreon. And as always, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.